Hello guys, my name is Craig and welcome to Peri Solutions. In today's video, we're going to talk about how we calculate the distance from a point to a straight line under vectors. But before we start, please make sure that if you're new to my channel, you hit the subscribe button and turn on the notification bell so that you don't miss out on any new videos. Okay, so the distance from a point to a line, right? This, in other words, is the shortest distance. That is the distance in the direction perpendicular to line L, right? So for this, right, let's say we need to calculate the distance from point P to line L, which is the perpendicular distance, right, which we are saying is the shortest distance. And we let Q be the foot of this perpendicular, right? So for us to calculate this distance PQ, right, what we need to do is that we need to calculate the coordinates of Q, right? But for us to calculate the coordinates of Q, we can use the fact that PQ is perpendicular to line L, and you can find the scalar product of the vector PQ in the direction vector of line L, right? And so now let's look at an example whereby we're required to find the distance, right? So this example says find the distance of point P from the line R, whose equation is R is equal to minus 430 plus T 12 minus 4, right? So that's the distance that we want, and we're given the coordinates of point P. So we know that if we're to express this vector equation, it's giving us the position vector of any point along line L, right, such that we can actually say Q, right, is equal to the position vector of Q is equal to minus 4 plus T, 3 plus 2T, then minus 4T, right? This is the position vector of Q, right, such that if we need to calculate vector PQ, we're saying that Q minus P, right? Then this would be minus 4 plus T, 3 plus 2T, minus 4T, and then minus 331, like this, right? Such that we're saying minus 4 plus T minus 3, we get a minus 7 plus T, and 3 plus 2T minus 3, we get a 2T, and minus 4T minus 1, this is minus 4T minus 1, like this. So this is now the vector PQ, but we're saying that PQ is perpendicular to line R, which implies that the scalar product of vector PQ, right, and the direction vector of line L, which is 1, 2, minus 4, 1, 2, minus 4, 1, 2, minus 4, should give us 0, right? So this is going to help us calculate the value of T, because now we know PQ already, so I think minus 7 plus T, 2T, and then minus 4T minus 1, right, dot 1, 2, minus 4, should give us 0. So minus 7 plus T plus 4T minus, actually it's plus, because here I'm just saying 1 times minus 7 plus T, that's minus 7 plus T, then plus 2 times 2T, that's 4T, then plus minus 4 times minus 4T, that's 16T, and minus 4 times minus 1, that's plus 4, this should give us 0. And now let's solve for T. This we've got 21T being equal to, that's a minus 3, which will give us a 3 here. So T is 3 over 21, which is 1 over 7. So now we can substitute for the value of T in our PQ, right? Such that PQ is minus 7 plus 1 over 7, minus 7 plus 1 over 7, to give us minus 48 over 7, so minus 48 over 7, and then 2 times 1 over 7, that's 2 over 7 definitely. Then minus 4 times 1 over 7 minus 1, that will give us minus 11 over 7. Right? So this is our PQ, such that if we now need to calculate the magnitude of PQ, right, we're simply saying the square root of this squared plus this squared plus that squared. So we're saying root of minus 48 over 7 squared plus 2 over 7 squared, 2 over 7 squared, then plus minus 11 over 7 squared. Right. So here we are saying square root of minus 48 over 7 squared plus 2 over 7 squared plus minus 11 over 7 squared. This should give us the magnitude that we want, and this is equal to approximately, this is 7.04. So this is the magnitude that we get. So this is how we calculate the distance from a point to a line, right? And then now we shall attempt those two questions. So allow me to erase this. Okay, so for number 1A, we're told that the line L passes through the points A and B. Find the vector equation for L. So first of all, we need to find the direction vector AB. So direction vector AB shall be given by, right, this shall be given by B minus A. So 2 minus 3 is a minus 1. Then 0 minus minus 1 is a 1. And then 2 minus 2 is a 0. So this is our direction vector, such that the vector equation is equal to, there we can just use any of those 2 points for the position vector. So if we pick A, right, then say plus T minus 1, 1, 0. This will be the vector equation for 1A, right? And then moving on to part B now says C is the point 9, 1, minus 6. Find the coordinates of point D such that CD is perpendicular to L. Right. So now what do we need to do? So if this was our line L and this is just a random point C, right? And then we're told that CD is parallel to L. So if we let this be D, and then this can be any random, right? So the position vector of D, we can work it out from the vector equation because we know it is just represented by, you can say D is 3 minus T, then minus 1 plus T, and then 2. So this is the position vector of D, right? And then we know that C is 9, 1 minus 6. So in actual fact, we can calculate CD. So CD will be equal to D minus C. So we're saying 3 minus T minus 1 plus T, then 2. And we're subtracting 9, 1 minus 6. Right, this will give us minus 6 minus T and minus 2 plus T, then an 8B. So this is our CD, right? And then CD being perpendicular to L, we can find the scalar product of the vector CD and the direction vector of line L. So minus 6 minus T, minus 2 plus T, then 8, right? Dot, minus 1, 1, 0, should give us 0, such that, let's say minus 1 times minus 6 minus T, you get a 6 plus T, then 1 times minus 2 plus T, you get a minus 2 plus T. This should give us 0. So 2T is equal to minus 4, then T is equal to minus 2. Right, so CD would be equal to minus 6 minus minus 2, that's minus 6 plus 2, which is minus 4, and minus 2 minus 2, that's minus 4, then we've got minus 8 there, right? But we're required to find the coordinates of the point D, right? So in other words, so this wasn't actually necessary, because if we need the coordinates of point D, we can simply substitute T here, right? Such that we've got D being 3 minus minus 2, that's a 5. Then minus 1 minus 2, that's minus 3, 2. So the coordinates of D would be 5 minus 3 and 2, like this. Then part C now says calculate the length of D, of CD. So now we are going to substitute this T into CD. Then we get this. Then the magnitude of CD shall be equal to square root of minus 4 squared, that's 16, plus minus 4 squared, 16, plus 8 squared, which is 64, right? Which is root of 32 plus 64 will give us a 96, right? Then this would be root of 96 is equal to 4 root 6, right? So we can actually leave it in set form. So 4 root 6 is the length of CD, right? So this was number 1. And then now let's quickly look at number 2. So number 2 says that find the distance from the point this 3 minus 1 minus 2 to the line to that line. So let's call this point, let's change this. So let's call this point X, right, which is 3 minus 1 minus 2, and let's call the foot of the perpendicular, let's let it be Y, right? So now, first of all, we know that Y, right, the position vector of Y from the vector equation will simply be minus 4, right, minus 4 plus T, then 3 plus 2T, and then minus 4, right, like this, right, such that xy, right, vector xy would be y minus x, which is minus 4 plus t, 3 plus 2t, then minus 4, minus 3 minus 1 minus 2, which would give us minus 7 plus t, then 4 plus 2t, and minus 2, like this. So this is vector xy, right? And we need the distance from x to y. So now we shall find, because we know xy is perpendicular to r, so we shall simply find the scalar product of this, right, of vector xy and the direction vector of line L. Direction vector being 1, 2 minus 4, and this should give us 0. So 1 times that, we get minus 7 plus t. 2 times 4 plus 2t, we get 8 plus 4t. Then minus 4 times minus 2, we get an 8. This being equal to 0. Then adding the t's, we get a 5t. Right, being equal to, this is 16 minus 7, that's it, plus 9, 0. So t is equal to minus 9 over 5, right, such that xy is now equal to minus 7 minus 9 over 5, minus 7 minus 9 over 5 will give us minus 44 over 5, minus 44 over 5, and then 4 plus 2 times minus 9 over 5, this will give us 2 over 5, and then minus 2, let me put minus 2 here, right? But again, if you factor out 1 over 5, we'll get a minus 44, 2, then minus 10. So you can simply say the magnitude, right, So we can say the magnitude of x of xy would be 1 over 5 root of minus 44 squared plus 2 squared plus minus 10 squared. Like this, then this in square brackets. This will be 1 over 5 root of what? Let's see. So minus 44, root of minus 44 squared, right, plus 4, then plus 100, sorry, right, plus 4 plus 100. That will give us 2, this will give us 1 over 5 times 2 root of 510, like this, which is 2 over 5 root of 510. So this is the distance from point 3 minus 1 minus 2 to line r is equal to minus 4i plus 3j plus ti plus 2j minus 4k. And this was how we calculate the distance from a point to a line. Please feel free to leave a comment, drop a like, and don't forget to subscribe. Thank you.